Hello and welcome to today's Lightboard Tech Talk. Today we're going to be talking about Load Balancer 2.0 or Rise of the ADC. If you enjoy watching this video, please don't forget to like it and of course subscribe to the channel so you can get access to more videos as we release them. So today, Load Balancer 2.0, Rise of the ADC. What do I mean? ADC stands for Application Delivery Controller. So let's write that down. Application Delivery Controller. And why do we have this term ADC? Because sometime in the mid-2000s, we started terming that load balancers do more than load balancing, and it wasn't a proper term anymore. And that's not really the case today, but yeah, it is. So what is this all this other stuff that we're talking about that we created this new term? So traditionally, load balancers do what we consider to be quote-unquote load balancing. Number one, server load balancing. So server load balancing, SLB. And this is where you have clients connecting to a load balancer that is distributing the traffic to a pool of servers. And it's doing health checks, providing high availability. We have this virtual IP address, which the load balancer is hosting as a proxy for these servers, so that when the clients make the connections, they go to this virtual IP or VIP, and then the load balancer uses algorithms to make sure the servers are okay, health checks, and algorithms to distribute the traffic to the servers, server load balancing. Two, we have global server load balancing. Global server load balancing was introduced fairly soon after the load balancing technology came out in the late 90s. And it's different, but it's along the same concept, but now instead of load balancing servers, we're load balancing sites. So we have site A, we have site B. And this load balancer, it could be within here, but logically I'm going to throw it outside the sites. And I have clients, and when the clients make DNS requests for the application, the load balancer is doing health checks of the application at each site or the load balancers within the sites, determine the health, and then hands a DNS response appropriate for site A or site B. So DNS response comes back, and the load balancer says, you know what, client, you should be going to site A, or you should be going to site B. And this is based on DNS. So it's kind of like a dynamic DNS. And the cool thing is we can do it based on disaster recovery. So in other words, all traffic always goes to site A. Unless site A fails, then send it to site B. Or we can do it based on equal distribution of the sites, so they're both active. We can do it based on geography. So is the client coming from North America? Send them to the site that's in North America. Lots of cool things we can do with GSLB. And then soon after that, in the early 2000s, we're saying, you know what, load balancers, they're in this critical point in the network. They're sitting between the clients and the applications, and all the traffic's going through them. So let's start doing firewall or security to some degree. So now the clients are going through the load balancer, but the load balancer is now acting kind of like a traditional firewall, which it already did inherently because of the technology, and that's for another discussion, can allow or block the traffic based on different parameters, usually layer 3, layer 4 network information, source destination IP, TCP, UDP ports, etc., but can do some content things as well, potentially. But firewall is function number 3. And then we were saying, you know what? It's doing all this other cool stuff. It's manipulating the traffic and it can inspect the traffic going to these applications. Let's create a use case number 4. And let's call this, I'm going to call this edge authentication. Edge authentication is something that at Kemp we call the product ESP, Edge Security Pack. This is where we can do two-factor authentication. We can do custom logins. We can do Kerberos, Active Directory login. We can do all sorts of cool stuff in terms of single sign-on. So we can support SAML. We can support OAuth. And now when the client makes a connection through the load balancer to the server, the load balancer is going to do some pre-authentication before the client actually gets to the application itself through some sort of authentication database like Active Directory or something. So edge authentication, firewall security, GSLV, server load balancer, we're doing a lot. Well, let's throw some more in. Let's see if I have room on the screen. I'm going to add 5. So we do security already at a network layer, but the most popular protocol and really the dominant protocol on the internet is HTTP/HTTPS. So let's include the ability to do web application firewall or WAF. So now when the client makes a connection through the load balancer to the web servers, the load balancer can look at the content. And based on rules that we support or you configure into the load balancer, you can allow, deny certain information, such as you don't want social security numbers to be passed in clear text. You don't want credit card information being passed in, or you don't want any sort of buffer overflows or SQL injection attacks, things like that. For example, we can now support things like PCI, DSS for the financial industry. We can support, in general, things like OWASP top 10 vulnerabilities. So we know the top 10 vulnerabilities that we see on web servers. We can create rules, protect against these OWASP top 10 attacks. There's lots of cool things we can do with a WAF. And the last thing I want to mention, this is something that Network Chuck, a guy that we talked to recently, who's a huge influencer on YouTube in terms of network technology, really showed how you can use the load balancer as a reverse proxy. So you can use the load balancer to take clients to go through the load balancer and access through a single port and a single IP address multiple applications that are different. One might be a web server. Another one might be storage. One might be a dynamic PHP or WordPress or something like that. Different types of servers and applications you can now access through the reverse proxy that's acting as a gateway, security gateway into these applications. And the cool thing here is not only can we act as a reverse proxy, we can now add on the functionality of the WAF capability so that we're providing WAF protection on top of that reverse proxy. We can support edge authentication, so we can support different ways of logging in using two-factor authentication or any other method, single sign-on. Into all these technologies can be combined, mixed and matched in different ways to really provide a robust infrastructure to manage your application delivery system architecture. So if we look at this, again, our core technologies that we're talking about, server load balancing, global server load balancing. But we have all these other things that we can do because of the function and the placement of the load balancer in the network in front of the application between the clients and the applications. So therefore, we came up with the term ADC, Application Delivery Controller. Now, I'm not going to get mad at anybody if you don't use the term ADC, you didn't know what it was, and you use the term load balancer. but kind of think of the terms today almost interchangeable. But usually when I use the term ADC, I'm usually talking about load balancing plus. So it is my load balancer that is fancy with fancy features. So this is the evolution of the load balancer and the creation of the concept of the ADC, and this is what we have today. Hopefully this was a useful Lightboard Tech Talk. If you enjoyed this, please like this video, and again, subscribe to the Kemp channel so you can get more content from us like this in the future. Hopefully this was good, and have a great day. Thank you very much.